With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The circuit shown in figure is a series LCR circuit connected to an AC source. This circuit has many important applications in practical electronic systems. In the given circuit, L is equal to 20 mH and frequency of applied alternating potential differences omega is equal to 8000 radian per second. Initial phase of applied potential difference has such a minimum value that initial value of instantaneous potential difference is half of its peak value, while initial phase of current is the circuit has such a minimum value that initial value of instantaneous current equals its peak value. So we have a LCR circuit in which we have been given the value of the inductance and we have been given the frequency of the applied potential difference. Also, we have been given some information regarding the initial value of instantaneous potential difference and instantaneous current. Then we also observe that current in the circuit leads the net voltage across the circuit. So we know that current is leading in this circuit. It is given that peak values of potential difference across R and L are. So we have been given the peak voltages across the inductor and the resistor. Then we have to find out the value of resistance. So we have been given the value of peak potential difference across the inductor. So the peak potential difference across the inductor is achieved when the current is also at its peak value. So for the inductor, the peak current multiplied by XL, that is the inductive reactance of this inductor. So the peak current from this equation will be equal to the peak voltage upon XL, which means the peak current will be equal to the peak voltage across the inductor, which is given as 20 volts. So 20 volts, and XL is given by omega into L, where omega is the frequency of alternating potential difference and L is the inductance. So that means 8000 radian per second, that is the frequency of the alternating potential difference here, multiplied by the inductance, which is 20 into 10 raised to the power minus 3 H. From here, the peak current will be equal to 2 by 16 ampere. Now, since this is a series circuit, so this peak current will also be the peak current for this capacitor, and it will also be the peak current for this resistor. So that means the peak potential difference for the resistor will be equal to VR into I peak multiplied by the resistance. From this equation, I can find resistance as the peak potential difference across the resistor divided by the peak current. Now the peak potential difference is given as 25 volts and peak current we found out as 2 by 16 amperes. So from here, the resistance is 200 ohms. So that means the correct answer is option number A.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.